Alright, so the exponential distribution looks kind of like this. Just wanted to clarify a few things. It's defined on the interval 0 to infinity. That's t equals 0 to infinity. So if you were to integrate that, okay. So if you take a look at that, let's let u equal minus t over r, right? Then du dt, du would be equal to minus 1 over r dt. So I have a minus of a du. So it's negative e to the u, right? And then that is the antiderivative. So then the question is, all right, well, that's neat. So what if you go from 0 to infinity? It's supposed to equal 1. Put infinity in, you can't put infinity in. So you do this. Remember, this is an improper integral. So the limit of that is t goes to infinity is 0. Minus, and then you plug in the 0 and you get, for t you get a 1, so you end up getting plus 1, so yay, it works. Okay, so then the person might ask, well, okay, that's nice, so what would happen if I wanted to find something like, for instance, the one that this one I saw on one of the homework assignments was something like 10% of all wait times are greater than look up the one I was looking at, I guess. Greater than 16 seconds. Alright, so 16 seconds. Well, wait a minute, greater than 16. So you mean to tell me you want to integrate from 16 to infinity then, is what you're saying. And I would agree with you, except that kind of I would. Well, kind of I would. And you could do this antiderivative again, but that just seems silly. It really does. So in reality, what I'd rather do is think about it in this way. I'd much rather go from 1 minus the integral of 1 over r from 0 to 16, you see, and then of this guy here. I'm just go ahead and write it out. But hang on a minute, I'm not done yet. I know this has to equal 0.1. Okay? So right off the bat, that seems fairly straightforward. Wait, I already know what this antiderivative is, so two things I can do. I can subtract, I can end up with 0.9 on this side, and I could add this integral to the other side. And when I add that integral, what I'm going to end up with is like that, right? Well, now wait a minute. We already know the answer to this situation. It's simply going to be e to the minus t over, not t over, 16 over r, okay, minus that's a negative, minus a minus, and you put a 0 in there, you get minus a minus 1. So when I do this, this is a plus 1. I minus over here, I'm going to get minus 0.1. So let's make them both positive. Take the natural log of both sides. So r is equal to negative 16 over the ln of 0.1. Come on. .94, that's what r would be. Okay, so it's kind of an easy-ish sort of a problem. It can be done in several ways. I think that's probably the easiest way to do it. Some of you have had statistics before, so you may remember the z distribution. That is just a normal distribution with a standard deviation of 1. Right, so if I want to know the probability that I'm less than or equal to 1.6, well, it's over here somewhere. Okay, well, it's the same as the integral of the normal distribution, the standard normal, that is normal 0, 1. And so that actually is this formula right here. It is 1 over the square root of 2 pi e to the minus x squared over 2 dx. Or not, yeah, dx. And so again, we want to go from negative infinity to 1.6. Now remember, those are standard deviations, and so I can show you what that would look like in Desmos. And of course we could do it in other formulas too. So I could use my TI-89. What you'll find is that that guy is not going to integrate well regardless of how you do it. So if I come in here, 1 divided by the square root of 2 pi, and then I'm going to do the integral, come on, the integral of from negative infinity. Now you're like, where do I find infinity? Is it on one of these functions? Do I find it in here? You're like, oh no, what do I do? Well, you do several things, but I think the easiest thing to do for most people is just to pick a fairly large number. Okay. Now, is that really going to change anything? No, and the reason it's not going to change anything is this. In statistics, we talk about, hey, the probability that you are, that you're like even 2 standard deviations above the mean is basically impossible. Okay, it's next to nothing chance of that happening. Okay, and so if you're out there, let's say 1,000 deviations from the mean, there's really no chance that just happened. Okay, way out there. So the idea is this is going to 0. So the idea is you see it's 0.945. Now someone might readily say, well, Jay, 1,000 isn't very close to infinity, and I would argue that you're 100% correct. You can add as many zeros as you want. At this point it says undefined because it says I don't know what to do with that, Jay. But what that really means is that part right there is going to 0. But when you put it in that big of a number, it goes, I don't know what you want me to do, Jay, and it just quits. Okay, so that's how you would do about that one. In reality, when you take a stats class, what we do in stats class is we show you how to do things like, well, either in Excel or we could do it in the TI-84, 89 calculators or whatever. We do what is called the standard normal distribution on a calculator. Or some people have been taught back in the day, like me, you were taught to look at a stupid table of data. That table of data really was just the answer to about a bazillion hard, nasty integrals that someone had done and put into a big table for us. Gosh, what are you doing, Jay? Sometimes I get too busy talking and I'm not paying attention to what I'm doing. norm.s.dist. And so what I'm going to type in is I'm going to type in 1.6, comma 1. Oops. And what that does for me is it gives me the probability that x is less than or equal to 1.6. And there's our answer. You're like, well, what if I wanted greater than? Then I would take 1 minus this guy. Okay, and that's kind of a neat way to do it. Now, your book also asks you questions and gives you some heads up when it comes to just the regular normal distribution. So the regular normal distribution could have any weird kind of mu it wants to have. Doesn't make any difference. It could have any standard deviation it wants to have. Okay? And so the formula then is simply this: 1 over 2 pi square rooted, and then times sigma, which is the standard deviation, times the integral of e to the negative x minus mu squared over 2 sigma squared. and then dx, of course. Okay? And you're like, my God, that's gross. Well, kind of, but it's not hard. So, for instance, suppose I told you that mu is equal to 70 and sigma is equal to 3. What's the probability that x is, well, let's just pick one here. Let's say x is between 62 and 74. Now remember, whether I make them equal or not equal does not matter at all. Okay, so the probability of 62 is 0 in either case. Alright, so let's come back to this guy here. Let's get rid of this garbage. And I said I wanted to go from 62 I said, to 74. And now remember, out front we got to remember to add our times 3. No. There we go. And then in here, I'm going to do parentheses, x minus 70, parentheses, divided by, parentheses, 2 times sigma squared, which is 2 times 9. And you'll see it's about 90% chance of that happening. Okay. Now, in Excel, it goes like this. You can do it in Excel. You can do it in your TI-84, 89 calculators too. The thing is, when you're talking about everybody uses the normal distribution, so we have to have a way to make it so people can understand how it works. So in this case, we have x would be, what did I say? Did I even give a number? Oh yeah, 74. I forget what I said. I said between 62 and 74. Well, if 62 is over here somewhere, I'm going to find from there down. And if 74 is over here somewhere, I'm going to find from here down, and I'm going to minus the two of them. So I'm going to do two problems. So I'm going to take 64, comma, 70, comma, 3, comma, 1. And equal, copy that. Change this to 74, 72, 72. So you want to know the difference between them is simply this one minus this one. Okay? And I'm pretty sure that's what we got on Desmos, 904. We got 904.9. Beautiful. That's awesome. Okay? So that's the game. That's kind of what you're going for with that kind of a deal. Oops. Excuse me. Like there's one other one I wanted to mention. Just didn't want this to be a big problem for you. Oh yeah, that was another one that kind of came up that I didn't realize that it was on here. I'm gonna go ahead and just show it to you like this. Excuse me. So sigma squared, by definition, is the integral across the region. Okay. X minus mu squared times p of x dx. First thing I always like to do is distribute that all the way out. It's x squared times p of x minus 2x times mu times p of x minus mu squared times p of x dx, 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 integrate, integrate, integrate. Yes? Now, this first guy is new. You've not seen him yet. I'm going to define it momentarily. This guy here I can rearrange and bring the 2 mu out front. Well, by definition, by definition, this guy right here, this integral is mu. That's by definition. It's what we call the expected value. It's the integral of x times the p of x's across the entire region. Okay? Now, this mu squared is a constant, so bring it out. What happens if you integrate a PDF over its entire region? Well, by definition, it's equal to 1. So what you end up with is, oh, this should be plus mu squared, sorry, plus mu squared. So what you should end up with here in this dealio is you should have this this integral of this x squared, which I don't know what that is yet. In the middle, we're going to have minus 2 mu squared, and then we're going to have a plus a mu squared here. Or in other words, minus mu squared. Okay? So then, how do I integrate this guy? Not very hard, though, I can tell you that right now. So, if we're talking about, well, let's talk about an exponential function. Let's say my exponential function was an actual real life one. So my actual value function might have been this guy here. Okay. And if I wanted to integrate that with respect to t, now again we know that if I integrate it from here to here, okay, it equals 1. That's fact. Okay. You might be aware, though, this is kind of a big deal. It said to integrate from negative infinity to infinity. Well, this function didn't exist from negative infinity to 0, so there's no area there. Okay. Now, to find the mean, you would simply take the integral of x times, not x, in this case it wouldn't be x, it'd be t. T times e to the minus t over 3 dt. And this guy right here is what we refer to sometimes as the expected value, or the mean. Now, again, that's over from 0 to infinity. Okay. Now you're like, well, I can't do that on my calculator or on Desmos. Yeah, you can and you can't. So you kind of have to goof with it a little bit. I'll show you how I would do this as an approximate value. But it's kind of a big deal, too, to be able to see it from a couple different ways. So I'm going to go to 1,000. And then x times e to the negative x divided by 3. There you go. It's 3. What do you? What? The mean is 3. That's correct. The mean is always equal to that r value. That's right. Okay. Well, what if I did x squared? I don't know. Let's find out. Well, so to find sigma squared, I would need to find 1/3. It's x squared times, not x squared, it's t squared times e to the minus t over 3 dt. Okay. Minus 3 squared, because that's the mean squared. So I come over here and I look at this guy and I say, all right, well, the only thing I have to change in this function is come here and make this squared. And notice it comes out to be 18. Okay, 18. So this is 18 minus 3 squared is 9. So the sigma is squared is equal to 9. And that's something that you learn when you deal in a stats class. We make a big deal about this, sigma squared. Sigma squared for this particular, for an exponential function, is that r value that we just had squared. So we had 3 squared is 9. So that's kind of the idea of that. That's what I would do. If I had a TI-89, you can actually integrate on these guys real nicely too. By the way, again, I cannot stress this enough. On this test, you will show all your work, again, or you will not get credit. Not even a little bit of credit, not even partial credit, no credit at all. Getting a little tired of people coming up to me and, well, how come I didn't get a good grade? Well, because you cheated, obviously. You didn't show your work. There's this equation here. Notice that as x goes to infinity, it's going to be negative x plus 3 over e to the x plus 3. Well, that's going to 0 on the top end, obviously. And then if you plug in, for instance, 3, if you plug in 0, you will end up getting, excuse me. If you plug in 0 for x, you're going to end up with getting 3 for the value of this thing. Okay? And so that's nice. And then you're like, well, what if I wanted to do the antiderivative of this x squared, like so? Okay, and again, there's that. If you plug in infinity, it's going to be this quadratic over e to the x. Well, e to the x wins, so it's 0 on the top end. Put in zeros, you're going to get a 1 here for the e part, and you're going to get negative 8. You're going to get a minus 18, which is the answer we just got. You could do this. You could go comma, 0, comma. And it's that number right there. If you hit diamond enter, you will see that it's basically 18. It's not perfect. It's not perfect because we did an approximate value. And I didn't go all the way to infinity. I'm going to hit cancel. And I'm just going to clear that and grab this one up here. And go diamond enter. And okay, so the computer does not care for that many decimal places. So what I normally do is, if I'm doing this on the computer, on a calculator, I don't normally approximate like this. You can get a pretty decent approximation for it. If I'm doing it this way, I will just get rid of these guys. Take the antiderivative. Oh shoot. Take the antiderivative, which I just did, and then evaluate it by hand. So what I would do is I think about this, well, if this is going to infinity, this e to the x over 3, that's going to be in the denominator. It means the top end's going to 0, so it's going to be 0 minus, and then if you plug in, if you take this equation here, give it to me, and go such that x equals 0, you'll see it's negative 18. So it's minus a minus 18. 18 is my answer. Okay, I hope that helps a little bit. I won't be asking a ton of that on the test. I might ask for an expected value problem, but I don't think I'll even do that. So I'll keep it pretty straightforward on the test, kind of like the ones I gave you in the review.